This is Math Minutes with Mr. White. All right, in this video, I'm going to look at something you probably covered in geometry class, the distance formula and the midpoint formulas. So let's start with the distance formula. So if I were to give you a graph and put two dots on it, these two dots are 1, 2, and 8, 6. And then I might ask you, what's the distance between those 2 points? And you see it's kind of an angle, isn't it? Now, we could construct a triangle, and then that line that we want to know the length of, is the hypotenuse of a triangle. Now, if you recall, there's a thing called Pythagorean's theorem that would allow us to figure out the hypotenuse if only we had the other two sides. Well, we have enough information here to get the other two sides. Let's focus on the y-coordinates first because they're the easiest one in this problem to work with. So let's focus on the 6 and the 2. So the top point's 6 high, the bottom point is 2 high. What is the difference between that? How long is that right-hand leg? It's going to be 4 units. Now what about the bottom, the base of this triangle? Well, let's focus on the x's. So, we're 8 over to the side and then 1. What is 8 minus 1? Looks like that thing would be 7 wide. So we have a triangle on our hands with 2 legs. One is 4 and one is 7. This is a right triangle. So we can use Pythagorean's theorem to figure out the hypotenuse. Often we call the hypotenuse c. I'm calling it d here because we're using the distance formula. Now, I haven't told you what the distance formula is. In a way, I'm proving to you what the distance formula is. So to figure out that distance, that hypotenuse, we can use Pythagorean's theorem. So a squared plus b squared equals c squared, right? We don't know what c is. We're calling it d actually in this problem. So I'm going to put a d where we have that hypotenuse c. A is going to be 4. So 4 squared plus 7 squared is d squared. So 16 plus 49, that makes 65 equals d squared. Now, how do you get rid of that square on that d? Hopefully you're thinking the square root. You put the square root on both sides, you see that the distance between those 2 points was the square root of 65. So a little bit more than 8. I didn't actually figure out the decimal. I'm sure it's between 8 and 8.1. So if I go to the next slide here and get this stuff out of the way for you, you can see that the distance between those 2 points is the square root of 65, a little bit more than 8. So we don't use the Pythagorean theorem normally on this type of problem. Instead, we're going to use something called the distance formula. So let's do this where we just have some generic points. Let's call them x1, y1, and x2, y2. Let's try to remember exactly what we did. Now, we did a square root at the very end. So I'm going to put a giant square root here. And then if you recall, we took the x's and we subtracted them. So x1 minus x2, and then we squared that. Remember the a squared? Plus, we had y1 minus y2, and then that number got squared also. Right there, that you are looking at what we call the distance formula. Giant square root of subtract the x squared plus subtract the y squared. Add them together, do the square root, and you have it. So that is what we call d. So let's look at an actual example where we don't have a graph this time. Instead, we're just given the 2 points, and let's see if we can figure out how to do this. So the distance between these 2 points would be giant square root. Now you see I put that formula up above. So we're going to subtract the x's. Here we go, and we're going to square it. Ready? 5 minus negative 3. We're going to have a double negative. We'll deal with that here in a second. Plus, now let's subtract the y's. The y's are 7 and 8. So 7 minus 8, and we're going to square that number. So underneath the radical here, underneath the square root, what is 5 minus 3? That's 8, isn't it? 8 squared plus negative 1 squared. All of that is under the square root. This is going to be 64 plus 1. 64 plus 1 is the square root of 65. So strangely enough, we actually got the exact same answer as my first example. So the distance between those 2 points you would report to your teacher as being the square root of 65. If your teacher wants a decimal, go to your calculator, plug it in, and see what you get. Let's try another problem. This one has some minus signs on it. I would encourage you to go ahead and pause the video and give a try to this problem and then check your answer here in a second. All right, the distance formula is a giant square root, right? And we're going to subtract the x's. So we have -9 minus -4. We're going to have to be really careful there. And then we're going to have to square that. Plus, and on the second part, we have 2 minus 5. And we're going to square that also. Okay, so the distance formula is the giant square root of -9 plus 4 squared plus, and then this is going to be -3 squared, which of course is 9. So let's pause for a second. I want you to think about this right here, this -9 plus 4. Now, I like to think about this as a who wins by how much. We've got 9 negatives and 4 positives. They get out there on the field and they battle it out. Who's got more? The negatives. By how much? Be -5, wouldn't it be? Negatives win by 5. Okay, and then on this second one, we still have -3 squared. Okay, we're really close to having our answer, folks. The distance would be the giant square root of 25 plus 9, which is the square root of 34. So the distance between those 2 points is the square root of 34, which is just a hair less than 6. So probably about 5.9, 5.8, somewhere around there. But the square root of 34 is the exact answer and would be the best thing to report to a teacher. Okay, let's move on. We're back to these points again. Your teacher might ask you to find the middle between the two. That's called the midpoint, the very, very center. It's on the line. It's right in the middle. Now, again, I want to kind of discover the formula so that hopefully you can remember it. So if we focus on the y's first again, because again, they're a little easier to work with. So the y's are the green highlighted items. And notice that I drew horizontal lines at 6 and 2 in green. Now the midpoint is right in between those. So how high would the middle be between 6 and 2? Well, 4, of course. So you see how I put 4 in for the coordinate on that midpoint. Let's now focus on the x's. The x's go from 8 to 1, or 1 to 8. So what's the middle there? What's the middle there? It's not 4, it's not 5, it's right in between at 4.5. Now, I'm going to show you a way so we don't have to guess this or even draw these pictures. So the midpoint is at 4.5, comma 4. So let's take a look at a formula that would help us to figure out these midpoints. How did we do that? How did we find the middle? How can you find the middle of two numbers? The middle of two numbers. You average them. You take the mean or average. You add them up and divide by how many numbers you have. Now we have two numbers, so we're dividing by 2. So that's the average of the x's. Some people call it the mean. I always call it the average for whatever reason. y1 plus y2 divided by 2 would be the mean or the average of the y's. That's the midpoint formula right there. You average the x's, average the y's, and you have your answer. So let's look at a problem where we can put this formula to work. 5, 2, and 1, 6. We're going to find the midpoint between the two of these. So the midpoint, we're going to add them up. The them I'm talking about, by the way, are the x coordinates, so 5 and 1. Add them up, divide by 2. Take the y coordinates, 2 and 6, add them up, divide by 2. I get 6 over 2 and 8 over 2. So my midpoint is 3, 4. You see how easy that was? We just averaged the x's and averaged the y's. Let's try another example, maybe with some minus signs thrown in. We're going to average the x's, we're going to average the y's, and get our answer. Super simple. -3 plus 2 all over 2, comma 6 plus negative 8 all over 2. And a lot of this you can do in your head. I'm showing my work because you're watching a video here. I want you to see the work. But this is pretty simple stuff, hopefully, and you could do a lot of this in your head. So we get negative 1 halves, and then on this side, we get negative 2 halves. And of course, let's go ahead and rewrite it more simply as negative 1 half, comma, negative 1. Negative 1 half, comma, negative 1. All right, I have one more example queued up, so let's take a look at this. We got lots of minus signs this time. There's something special going on here I wanted you to see. Here we go. Well, let's add the x's up. The midpoint, negative 3 plus negative 1 over 2. And then on the second one, we're going to have 4 plus negative 4 all over 2. Let's work it out and see what we have. So on this first set of coordinates, on the x coordinates, we get negative 4 divided by 2, which is negative 2. Now, what do we get on that second one? What is 4 plus negative 4? It's 0. 0 divided by 2. Now, don't freak out when you get 0. Remember, 0 is a number 2. We don't freak out when we see a 0. All right, we just work with it. 0 divided by 2 is 0. The midpoint between those 2 points is negative 2, comma 0. There you have it. All right, folks, we went over the distance formula. Remember, that was just an application of Pythagorean's theorem. No big deal there. That's where you subtract the x's, subtract the y's, square them. They're all under a square root. No big deal. The midpoint formula is even more straightforward. You average the x's, average the y's, and that's the midpoint between 2 points. So hopefully this made some sense to you. And if you like this video, be sure to like and subscribe to my channel. Also put your comments down below. I do appreciate to read those. All right, good luck. And until next time, this has been another edition of Math Minutes with Mr. White.